Okay, now tell me, is my screen visible? Aisha and Sanidhi?
Yes, ma'am.
Okay, so the topic is de Broglie's wavelength, right? De Broglie's wave theory, right? So this de Broglie wave theory, it gives a wave nature of electron, right? ये क्या कहता है हमें? It gives a wave nature of electron. And see, we know that electromagnetic radiation exhibits a dual nature, right? It behaves a dual nature होता है electromagnetic radiation. Okay. So de Broglie wave theory, we know that and what happens? Electromagnetic waves or electromagnetic radiations, they exhibit a dual behavior. They have dual nature, right? They act as wave as well as particle. ये particle की तरह भी behave करते हैं and wave की तरह भी nature होता है इनका. That's why they have dual behavior. Okay, so electromagnetic radiation, just like light. Suppose light. So light exhibits dual nature, dual type of behavior because it acts as a wave and it also transfer as a particle, right? So it can demonstrate wave-like properties like interference और जब का आपका interference होता है like your diffraction, right? So this is a wave type of nature, right? If something behaves like a wave, then they show this type of properties like interference properties. They will show diffraction properties, right? Now, do you know what is interference and what is diffraction, Sanidhi and Aisha? Do you know? Yes or no? Just tell me.
No, ma'am.
Okay. So interference is that yes, interference, right? So interference is that behavior or that properties when waves overlap. जब waves overlap करते हैं, so they can neither connect with each other and neither they cancel each other, right? जब इंटरफेरेंस नेचर वो होता है जब वेव्स ओवरलैप करते हैं एक दूसरे के राइट व्हेन द वेव्स ओवरलैप विद ईच अदर they can neither reinforce right they can neither reinforce each other or they cancel each other. That's the behavior which is known as interference. Okay, and ये interference जो nature होता है that's the wave nature of any particle. Okay, wave nature, wave behavior of any for example your electromagnetic, and the diffraction word you know very well. Diffraction word, आपने ये सुना है ये word diffraction. What is diffraction? So when we talk about wave, so when waves pass through an opening, right? किसी भी opening obstacle से जब wave pass होता है, right? So they spread out. They just spread out. That's the diffraction property. So split हो जाता है, right? They split or they diffract. Okay, just like in the case of prism. Prism के case में क्या कैसे होता है diffraction? They just white light just diffract or split into 7 colors, which is red here, right? So that's the diffraction. Okay, so this diffraction and interference, these are the wave-like properties, right? If something just behaves like a wave, तो ये property show करेंगे, like interference show करेंगे and diffraction show करेंगे. Okay, so electromagnetic waves, they just show just like a wave, they have wave type of nature as well as particle type of nature. And if something has particle type of nature, they show properties like photoelectric effect, right? Photoelectric effect, which we have discussed in the last class. Remember what is photoelectric effect? Aisha and Sanidhi?
Yes, ma'am.
Yeah, so that type of properties are shown by particle type of nature, right? So electromagnetic waves have dual behavior. वो particle type भी behave करते हैं as well as wave type. Okay, so they have dual behavior. Just remember that. And this de Broglie wave theory, it gives the wave nature of electron, right? We know that electromagnetic waves have dual type of behavior, but this de Broglie wave theory, it gives a wave nature of electron. ये किसके बारे में बताता है? वेव नेचर ऑफ इलेक्ट्रॉन के बारे में डिस्कस करता बताता है. ओके. Okay. Now see, according to this theory, so according to this hypothesis, and yeah, this is also known as a hypothesis, right? Because de Broglie ने कुछ prove नहीं किया था, ये just statement उन्होंने दिया था, just hypothesis, just predict किया था उन्होंने, right? So according to this hypothesis, any object which is in motion, right? If any object which is in motion will have a wave associated with, right? कोई भी ऑब्जेक्ट अगर मोशन में है, right? If it is in motion, तो it will have some wave associated with it, right? And this wave is called matter wave, right? This wave is known as matter wave or de Broglie wave. Okay, again I'm repeating. What does de Broglie said? So de Broglie said that any object which is in motion, right? So it will have wave associated with, and this wave is known as matter wave or de Broglie wave. Okay, and the wave properties are very important only for particles of a small mass and high velocity, right? Wave properties किसके लिए important होगा? That type of particle which have a small, very small mass and they have high velocity. उसके लिए ये theory applicable होगी, ये de Broglie wave theory applicable होगी. Got it?
Yes, ma'am. Yes, ma'am.
Okay. Main thing is the equation. Okay. Main thing is the equation, the formula. So according to Einstein, see, according to Einstein, we know that E is equals to mc square, right? But according to, if we mark it as equation 1, but according to Planck quantum theory, E is equals to hc upon lambda, right? Just mark it as equation 2. Now from equation 1 and 2, from equation 1 and 2, right? So 1 and 2, mc square, mc square is equals to hc upon lambda, right? फ्रॉम 1 and 2, E इक्वल है तो ये भी इक्वल होगा, mc square is equals to hc upon lambda, right? Now cancel it. 1c and 1c will cancel out, and from here the lambda wavelength is equals to h upon m into c. Clear? So lambda is equals to Planck's constant divided by mass into your velocity or speed, you can say. Okay, so this is the relationship between the wavelength and your Planck's constant and mass and your velocity. Now, this is the speed, right? When we talk about the light, speed of light, so we will use c over here. But when we talk about speed or for any object, जब हम लाइट की स्पीड की बात करेंगे तो we will take c, right? And the c value you know very well, 3 into 10 raised to the power 8 meter per second. But when we talk about any object, so for any object with velocity v will be lambda is equals to h upon mv, right? आप c की जगह पे v substitute कर दो, तो lambda will be equals to h upon mv. And yeah, lambda is the wavelength. Okay, h is the Planck's constant, m is the mass of that particle, and v is the velocity of that. Clear?
Yes, ma'am.
Okay, now see. So h is equals to, okay. Now see here, we know that what is momentum? So momentum is the product of mass and velocity, right? So can we substitute it here? Lambda is equals to h upon p, right? Because since we know that mv मास वेलोसिटी इज योर मोमेंटम एंड मोमेंटम को हम किससे डिनोट करते हैं, p से, राइट. Okay, so lambda is equals to h upon p. Now see, okay, there is no space. Okay, no problem, I'm just rubbing. Okay, so lambda is equals to h upon p. Now see, we know that kinetic energy, what is the formula for kinetic energy? Half mv square, right? Now from here, 2 into kinetic energy will be equals to mv square. Okay. Now, if we multiply both sides by m, then there will be no problem, right? कुछ भी changes नहीं होगा. So can we just multiply both sides by mass, right? So you will get 2 into m into kinetic energy is equals to m square v square, right? Now see, 2m into kinetic energy, this will be equals to mv whole square. And mv, we know that what is mass into velocity, so it's momentum, right? So p square. So from here, p will be p square it is. So this will be under root of 2m into kinetic, 2 into mass of that particle into its kinetic energy. Okay, so that's the relationship between the your momentum and kinetic energy. So can we substitute it over here? The value of momentum. So the value, when we substitute the value of momentum here, so lambda will be equals to h upon under root of 2m into kinetic energy. Right. So that's the formula which we will use to calculate the wavelength when the kinetic energy is given. Clear?
Yeah, ma'am.
Okay. Okay, next see. Now see, if electron is accelerating, right? If electron is, because it's in motion, तो वो acceleration है. जब कोई भी object motion में होता है तो उसके साथ, और अगर if it has some mass and some velocity, right? So it must be in acceleration. So electron, when the electron is in motion or acceleration, so by applying voltage, right? For example, when you apply some voltage, the electron is in acceleration, right? Voltage V अगर आप apply करते हो, the electron is in acceleration. Then your kinetic energy you will take in electron volt, right? Kinetic energy आप किस unit में लोगे? You will take it as a electron volt because you are applying some voltage and the electron is accelerating, right? तो voltage apply कर रहे हो तो the kinetic energy will be in electron volt. Clear?
Ma'am.
Now see, circumference circumference of an orbit is integral multiple of wavelength, right? So what does this mean? If the circumference of any orbit, it's an integral multiple of its wavelength, and it is equals to, we know that what is circumference, so 2 pi r, right? So 2 pi r is equals to the integral multiple of wavelength, means n lambda. N lambda. Now what is n over here? So n is your the number of waves. What is n here? So n is the number of waves. For example, if for example this is an orbit, right? This is an orbit, and this orbit it consists of three waves, right? यहाँ पे ये there are three waves over here, right? So what will be the circumference of an orbit? So here in this case, 2 pi r is equals to, we know that 2 pi r is equals to n lambda, right? So 2 pi, this is 2 pi r is equals to, there are three waves associated with this wave, right? Three waves. So what is n? The value of n is 3. So this will be equals to n lambda. Clear? Now suppose if there are five waves, one or six waves, 1, 2, 3, 4, 5, and 6 waves. So your 2 pi r is equals to 6 lambda. Okay, just remember that. So n is, what is the circumference of an orbit? So circumference of an orbit is always equals to the integral multiple of wavelength, right? N lambda. Okay, so 2 pi r is equals to n lambda, and n is what? N is the number of waves. Clear?
Yeah, ma'am.
Okay, so we know that since 2 pi r circumference is equals to the integral multiple of its wavelength, right? And so 2 pi r is equals to, what is the value of lambda? So we know that lambda is equals to h upon mv, right? h upon mv, Planck's constant upon. So further हमने ये derive किया था, lambda is equals to h upon mv, right? This formula. So we can substitute it over here. Okay, so from here, okay, so 2, we are just exchanging it, right? Mass को इस side ले जाओ and 2 को इस side ले जाओ. So it will be mvr, right? 2 pi को मैं इस side ले जा रही हूँ and mass को इस side ले जा रही हूँ. So mvr is equals to n into h upon 2 pi, right? mvr, right? So mass into velocity को मैं ले जा रही हूँ, mass into velocity, right? I'm just exchanging mass into velocity over here and 2 pi over here, right? So you will get mvr, mass into velocity into your r radius, is equals to n into h upon 2 pi. Okay. Now see, this mvr is your angular momentum, right? Angular momentum का ये formula होता है mvr. So mvr is equals to angular momentum, and your angular momentum is your n into h upon 2 pi, right? N into h upon 2 pi. And n is the number of waves associated with that. Okay, so n into h upon 2 pi. Clear? Now see, n is the shell number. Shell number according to Bohr, right? जो हमने Bohr theory में देखा था, तो n was the shell number. But according to de Broglie, n is the number of waves. According to the de Broglie, n is the number of waves. Okay, just remember the difference. When we talk about the Bohr theory, then n is the shell number over here. But when we talk about the de Broglie equation, the n is the number of waves. Clear?
Yeah, ma'am.
Yes, ma'am.
Okay, so de Broglie wave theory completed. The next topic is your Heisenberg uncertainty principle. Okay, so if you want to take this screenshot, just please take this screenshot. और आपको recording lectures तो provide होती होगी, right? Sanidhi and
Yes,
Aisha.
ma'am.
Okay, so you can make notes from there because today I have to complete this chapter and three topics are still left. Okay.
Okay, ma'am.
Okay, so next topic is your Heisenberg uncertainty principle. Okay, so Heisenberg uncertainty principle. So what is that uncertainty principle? Right, the first chapter mein I told you about what is uncertainty. So uncertainty is nothing, it's an error, right? As error in measurements. That's the uncertainty. So Heisenberg said that it is impossible to determine exact velocity and position of moving electrons simultaneously. Okay, so it is impossible to determine the exact velocity. What is the exact velocity and position of that moving electron? We can't determine it simultaneously, right? It's impossible according to Heisenberg. And this uncertainty means the uncertainty in equation is given by this, right? So it's delta x into delta v, which is greater than or less than, which greater than or equals to h upon 4 pi m. Okay, and now see this m is m को इस side ले जाओ, right? So this m we are taking it here. So delta x is into m del v is greater than or equals to h upon 4 pi. Okay, step by step, just understand this how it came. And now we know that mass into velocity, what is it? It's a momentum, right? So the mass into the change in velocity is equals to delta P, right? Which is the uncertainty. Delta P is the uncertainty in momentum. Delta X is the uncertainty or error in position. H, you know very well, it's a Planck's constant, and 4 pi. Pi value, you know very well, 3.14, right? So accordingly, you can calculate the uncertainty in measurements. Uncertainty, what is the error or uncertainty in position? You can just calculate it. So that's the Heisenberg uncertainty principle. Clear?
Yes, ma'am.
Aisha, clear? Any doubt?
No, ma'am.
Okay. So okay, let's do one question. Okay, so the question is a microscopic using suitable photon, a microscope, it use suitable photons, is employed to locate an electron in an atom, right? Within a distance of zero point 0.1 angstrom. So what is the uncertainty involved in the measurements of its velocity? Okay. So we just have to calculate the uncertainty in measurements of its velocity. Means हमें delta v find करना है. Okay. So and microscopic, this is the delta position, right? Position is given, right? So the uncertainty in position is delta x, right? What is the uncertainty in position? So it is denoted by delta x. So delta x value is given, which is 0.1 angstrom. Okay, and so according to the equation, we know that delta x into delta v is equals to, okay, see, here in the equation, no need to write the greater symbol. Okay, greater than equals to है, तो आप equals to put कर सकते हो in equation when you solve the numericals. So delta x into delta v, it is equals to h upon 4 pi. That's the formula. Okay, and we have to calculate the uncertainty in measurements of its velocity, right? So delta v is equals to h upon delta x into 4 pi. Now it's very simple now. Substitute the formula, so substitute the value. So what is the value of Planck's constant? Say 6.626 into 10 raised to the power minus 34, right? And delta x value, so the uncertainty in position is given 0.1 angstrom. So 1 angstrom, it is equals to 0.1 into 10 raised to the power minus 10 meter. Right? 1 angstrom is equals to 10 raised to the power minus 10 meter into 4 into, what is the value of pi? So it's 3.14, 3.14 into, so we are talking about the electron. So what is the mass of electron? Mass of electron is, anyone? What is the mass of electron? इतना जल्दी कैसे बोल सकते हो आप लोग? Couldn't recall? So it's 9.1
9.1.
into 10 raised to the power minus 31 kg. Okay, now solve it and you will get the value of uncertainty in measurements in velocity, delta V value. Okay, now solve it. So this will give you 6.626 upon 4 into 3.14 into 9. Again, simply you can just write 9. Okay, simplify करने के लिए equations को you can just simply write 9 into 10 raised to the power minus 34 into, ये दोनों क्या हो जाएगा? It will be 10 raised to the power minus 11, right? So 10 raised to the power minus 11, just will be not minus ऊपर आप ले जाओगे in the numerator, so it will become positive. So 10 raised to the power, I'm just simply adding it. 10 raised to the power minus 34 plus 11 plus this 31, right? Now solve this. 6.626 upon, okay, this 4 was a 16. So it will give you something 12.56 into 9 into 10 raised to the power. This will give you minus 34 plus your 42. 42. So it will give you 8. 10 raised to the power 8. Okay, so when you divide this 6.626 upon 12.56, so आपका approximate value आएगा, approximate value will 0.52, right? So आप 0.52 को 1 upon, simply I'm just writing the approximate value, not the exact one. Okay, so in the numericals, you can just use the approximate value. 1 upon 2. So 1 upon 2 into 9. यहाँ पे 1 upon 2 point something आएगा, which is 0.1, 2.1 something. Okay, so I'm just taking one, only 2. So 2 into 9 into 10 raised to the power 8. Okay, I'm just taking this approximate value to ease the equation. Now this 1 upon 9 to the 18, or 1 upon 2 ko you just write 0.5 upon 9 into 10 raised to the power 8. Okay, and simply you just write 5 into 10, right, into 10 raised to the power 8 upon 9, or simply you just take 5 upon 9 into 10 raised to the power, okay, this will give you 1 minus 1, so 7, 0.55 into 10 raised to the power 7. Okay, so that's the value, delta V value. Delta V value, or you can simply write 5.55 something आएगा, तो you can write 5.6. Okay, 5.555 something. So you can simply write 5.6 into 10 raised to the power 6, right? Because you are shifting one decimal here, right? So यहाँ पे minus हो जाएगा from the exponential form. So it will give meter per second. So what is the uncertainty in measurement in velocity? So it's 5.6 into 10 raised to the power 6 meter per second. Now tell me, is there any problem, any doubt in any step?
No, ma'am, no doubt.
Aisha, clear?
Yeah, ma'am.
So just write down the solution first. Done?
Yes, ma'am.
Okay, so the next topic is your quantum mechanical model of atom and Schrodinger wave equation. Okay, so quantum. So see, what is quantum mechanical model? So हमने quantum numbers, etc. We have done everything, right? But now, what is quantum mechanical model? What is Schrodinger wave equation? We will get to know. So quantum mechanical model, so it's a branch of science that takes into account this dual behavior of matter, right? So ये quantum mechanical model में it's a branch of science that deals with the dual behavior of matter, right? Which is called quantum mechanics, right? Quantum mechanic in the quantum mechanics subjects, we just study the dual behavior of matter, right? The wave nature and the your particle nature. Okay. And this model, this quantum mechanical model, it gives the idea about wave associated with electron, right? So how the wave is associated with the electron, and it gives the information about that. Next is the fundamental equation of quantum mechanics was developed by Schrodinger, right? He was a scientist who gave the fundamental equation of quantum mechanics. And the fundamental equation is this. The electron wave is described by the following equation. This equation, इसी equation से हम electron की wave को describe करते हैं, right? Now see what is this equation. So the change we will just take the second derivative. Okay. So the change in the this is psi. What is this? This is the wave function which is psi. हम इसे psi पढ़ते हैं. PSI psi. P silent होता है and we just said it psi. Okay. So the change in psi with respect to x, right? X, y, z here is coordinates. X, y, and z are coordinates. Okay. तो यहाँ पे x square d square of psi upon dx square plus d square, the change in your psi wave function with respect to y. Okay, y coordinate, the change in the wave function with respect to your z coordinate. इन तीनों का sum plus 8 pi square m into e minus v. E minus v into psi, this is equals to 0. Right? So this is the equation which is known as Schrodinger wave equation. Right? क्योंकि Schrodinger ने ही ये equation दिया था and it governs the electron wave. Right? It just describes the electron wave. Okay. So now see what is psi over here. So this symbols denote the wave function, which is psi, right? And m over here is mass. M here is the mass of electron, right? H, we know that H is your Planck's constant, right? And E is your total energy of electron. What is E here? So E here is total energy of electron. And V, capital V is the potential energy of electron. Capital V क्या है? Energy of electron. Right. So this equation shows the electron wave. Okay, so this is known as Schrodinger wave equation. Got it? So you just have to remember this equation. What is Schrodinger wave equation? तो आपको ये पता होना चाहिए. ये पूरा equation याद होना चाहिए. Okay, so just memorize this equation. And yeah, the solution of this equation, the solution of the Schrodinger wave equation, it gives the principal quantum number, azimuthal quantum number, magnetic quantum number, right? But it doesn't tell us about the spin quantum number. Okay, because psi indicates the amplitude of the wave. Amplitude and wave function बताता है, this is your psi. Okay, so just remember this equation. Any doubt in this equation, the wave mechanical model? Sanidhi and Aisha?
No,
What's the
ma'am.
symbol for psi and x square, y square, and z square?
This symbol, this is the change, the second derivative. जब जैसे आप derivative निकालते हो, like the change in the with respect to the rate of change, it shows the rate of change of wave function with respect to x, with respect to x coordinate. This x d square psi upon dy square, it shows the rate of change of psi with respect to y coordinate. Similarly, z coordinate. Okay, so just remember, because here there is some mathematics and I know you don't have mathematics. आपके पास maths नहीं है class 12 class 11 पे, right?
No, ma'am.
Okay, so you just remember this equation. Okay, so just remember and don't think how it came. Okay, इसका derivation जानने की जरूरत नहीं है, just remember this. Schrodinger wave equation is this. Okay, and d square psi, it just change बता रहा है, rate of change with respect to something, right? जब हम किसी भी चीज को d upon dt लिखते हैं, for example, just a second, d upon dt, right? For example, यहाँ पे कुछ भी है like x square. Okay, so d upon dt is the rate of change of something with respect to time, right? Time के according, time के respect में ये कैसे change हो रहा है, it just tells us about that. Similarly, d square psi upon dx square, it just tells the rate of change of wave function with respect to x coordinate. Similarly, y coordinate, z coordinate. Okay, and this is the second derivative. It's not the first derivative. d2 हम लिखते हैं तो it's the second derivative. Okay, so just remember this equation. Okay, now see, there are important features of quantum mechanical model of atom. Okay, so according to this quantum mechanical model, the energy of electron in any atom is quantized. Okay, we know that energy वो कैसे exist करती है, quanta के की तरह exist करती है, like a small packets of energy which is known as quanta. Okay, so energy of electron in any atom, it is quantized, right? Means quantized means it can only have certain specific values. Okay, so see, and the psi is the amplitude of electron wave. Psi क्या है? It's the amplitude of electron wave and it has no physical significance. कोई भी physical importance नहीं है psi का, right? Psi has no physical significance. But आप psi square करते हो, right? When you do the square of this psi, so it gives the idea about the probability of finding electrons or volume, right? Psi square is the probability density. Psi square को हम क्या कहते हैं? It is known as the probability density, and it gives the idea about probability of finding electron, right? Probability क्या है finding electron का, right? वो बताता है, and it has a physical significance. If it is psi, then it has no physical significance. कोई भी physical importance नहीं है, but it is psi square, so it is known as probability density, and it gives the idea about the probability of finding electrons, and the finding volume of electron, right? And it has a physical significance, but it has not a physical significance. And the psi square value is always positive, right? Psi square जो probability density की value होगी, it's always positive. Clear? I know it's quite typical, but just remember this. Okay, remember the points, try to understand it. Okay, so the probability of finding electron at any point within the atom is always proportional to the psi square, right? ये हमेशा psi square के equal होता है. So probability of finding electron is maximum here, right? ये हमें क्या बताता है? Probability of finding electrons का idea देता है, and it has a physical significance. Okay, and just write down the one more point. The probability of finding electron, the probability of finding electron at a certain distance, at a certain distance from the nucleus is called its radial probability. Radial probability. Okay. If someone asks you what do you mean by radial probability, so what is radial probability? So the probability of finding electron at a certain distance, right? At a certain radius पे होगा, right? From the nucleus. So उससे हम क्या बोलेंगे? So it's known as radial probability. Okay. Here any doubts? So you can please ask. Asha and Sanidhi, any doubt, बच्चों?
No doubt, ma'am.
Okay. So next topic is your atomic effect. That's the last topic of this chapter. Okay. So atomic spectrum. So first, what is a spectrum? So what is a spectrum? So have you heard this word earlier? बचपन से आप पढ़ते आ रहे हो. What is a spectrum? No?
The band of 7 colors that's obtained when white light
Yeah.
goes.
Yeah. So the basically dispersion of light into a series of colors band. Okay. Series of colors. That's known as spectrum. जैसे आप विबग्योर के केस में देखते थे, right? Rainbow is the best example of this spectrum dispersion, right? So what is a spectrum? So the dispersion of light into a series of color bands is known as spectrum. Okay, and there are different types of spectrum. Okay, let's see what are these. First one is your continuous spectrum. So what is continuous spectrum? तो यहाँ पे word से ही पता चल रहा है what is spectrum, continuous spectrum. So when the spectrum has no gaps, right? कोई भी gap नहीं होगा spectrum के बीच, right? So that's a continuous spectrum. Okay, so continuous spectrum is what? When the spectrum has no gaps in between. Okay, just like your visible spectra, जैसे आपका rainbow होता है, there is no gap in between, so that's a continuous spectrum. Okay, next is your discontinuous spectrum. So what is discontinuous spectrum? So when the spectrum has gaps in between, right? In between the colors, so it is known as discontinuous spectrum. Okay, discontinuous spectrum. And yeah, just remember our atomic spectra, atoms के जो spectra होते हैं, और atomic spectra को we just call it as a line spectra also. So atomic spectra are discontinuous, right? Why it is discontinuous? We have discussed it, right? जब हम quantum mechanics हमने start किया था, so we have discussed the what is quantum, what is quanta, photons, right? So we know that at atomic spectra are continuous. Why? Because energy levels of electron is in atoms are quantized. It is exist in a small packets. Okay, discrete units होती हैं. Just remember discrete units, right? Discontinuous units होते हैं of packets, which is known as photons, right? Or quanta. Okay, so that's the atomic spectra. That's why atomic spectra are discontinuous. Okay, it's discontinuous. Like a packet, a small packets of energy होती है. That's why it is discontinuous. Okay, so that's the discontinuous spectrum. Now the emission spectrum. So what is emission spectrum? So emission spectrum are observed when the radiation is emitted from a substance that has absorbed energy, right? So when the radiation has been absorbed, right? So you will observe this type of radiation, this type of emission spectrum. Okay, so what is emission spectrum? So it's observed when the radiation emit. जब radiation emit होती है किसी भी substance से, right? So that has absorbed energy. जब radiation emit होगी, तो first the substance will absorb energy, right? Then it will emit those radiation, right? So it is known as emission spectrum. Then you will see the emission spectrum. Okay, I will show you the diagram of this. What is continuous type of emission type of later. Okay, let's first discuss the absorption spectrum. Now, what is absorption spectrum? So, absorption spectrum, it's a when the continuous electromagnetic wave, right, when it is allowed to pass through a solution, right. When you pass electromagnetic waves from any solution or gas, right, then the transmitted light is analyzed, right. Then you will see the transmitted light is analyzed, and we will get absorption effect. For example, if there is a container, right, इसमें कोई भी solution है, suppose that solution, there's a solution over here. When you pass the light, for example, Vibgyor, right, Vibgyor, okay, means you are just passing the white light, okay, and white light contains Vibgyor, the 7 colors we know very well. For example, if it absorb the solution, right, because we know that some type of solution or some type of substance, they absorb different types of wavelength frequency, right? Wavelength or different types of जो colors के जो wavelength होते हैं वो से absorb कर लेता है. For example, ये the solution, it absorbs the green light. Suppose when you pass a white light in this solution, right, through this solution, it absorbs green light. Okay, ये absorb कर लिया green light. Then when you up prism से जब ये pass कराओगे तो it will scatter into 7 colors. You will see a band of 7 colors, not 7 colors, because one color is absorbed here, right? One color absorbed हो गया, so you will not see that color. So you will see here web cure, not web, not G you will not see, right? वो absorb हो गया. The green color you will not see. It will not be seen by the eyes. O and R. Okay. So that's the absorption type of a spectrum, right? If it absorbs certain frequency, right? So you won't be able to see here on the band. Okay. So that's the absorption aspect. Clear,
Yes, ma'am.
Aisha?
Yes, ma'am.
Okay. Now see, just a second. Okay. Now see, this emission spectrum, it contains bright colored light separated with dark spaces. Right? See the diagram here. This is a continuous spectrum, right? You will not see any discontinuation in this, right? So this is a continuous type of a spectrum, just like a web cure. Okay, web cure के case में जब आप देखते हो, so that's a continuous spectrum. Now see, this is the emission spectrum. Right. See here, in the emission spectrum, it contains bright color light separated with dark spaces. Right. See, this bright color light with the dark space. यहाँ पे dark spaces है, and it will show the bright band over here. This type of emission is known as emission spectrum. This type of spectrum, जहाँ पे भी आप देखोगे, it is known as emission spectrum. राइट, जहां जहां पे एमिट हो रहा है, राइट, एमिशन हो रही है, तो वो कलर शो करेगा. स्पेक्ट्रम will show that color only, like red, yellow, green. You can see over here blue, right? So they are emission. Now see here in the last part, this diagram, absorption spectrum, right? So in the absorption type of a spectrum, it contains the dark lines, राइट. जो कलर्स की जिस कलर्स की फ्रीक्वेंसी एब्सॉर्ब हो गई, यू कैन सी ओवर हियर, सो it will be separated by, yeah, you can see over here, you will see the dark colors, dark line over here, right? See this dark line, this is the dark line, right? So these dark lines are shown by absorption, राइट. सो ये यहाँ पे एब्जॉर्प्शन, ये जो डार्क लाइन शो कर रहा है, उसकी फ्रीक्वेंसी जो हो गई है वो दैट इज एब्सॉर्ब, राइट, दैट्स एब्सॉर्ब. दैट्स व्हाई वहां पे डार्क लाइन सेपरेट हुआ है, डार्क लाइन शो कर रहा है, राइट. सो जस्ट रिमेंबर एब्जॉर्प्शन स्पेक्ट्रा or absorption spectrum, it contains dark colored lines which is separated by continuous colors, right? ये continuous, for example, यहाँ पे see, I just give you the example of this web here, right? तो यहाँ पे ये जो ग्रीन कलर जो एब्सॉर्ब हो गया, दिस ग्रीन कलर, so in the spectra, in the absorption spectra, it will be shown as a dark line, right? ये dark color line से show करेगा. Okay, if suppose यहाँ पे green colors भी absorb हो जाता, then red colors and violet colors, etc. So all these colors which are absorbed in this will be shown as a dark line. Okay, in the absorption spectra. Okay, see the difference between these. Continuous spectrum, there is no dark color or bright color line, right? In emission spectrum, so emission spectrum is always showed by bright color light, right? Bright color lines is separate होती है with the dark spaces. And this type of absorption spectrum, this contains dark lines separated by a continuous colored spaces. Okay, any doubt?
No, ma'am.
Okay. Okay, so the last topic is hydrogen spectrum. And this hydrogen spectra is very very important. इससे जो questions होते हैं, बहुत सारे ऐसे questions आते हैं एग्जाम में. One question is complete, is mandatory, right? One question from this always come. So just concentrate here. So what is hydrogen spectrum, right? So hydrogen spectrum is obtained by analyzing the light, right, which is emitted by discharge tube, right? So hydrogen spectrum हमें कैसे मिला? So the source of radiation here is a hydrogen discharge tube, right? Just like a cathode ray discharge tube. Similarly, in this case, the source of radiation is a hydrogen discharge tube, right? जब जिसने hydrogen spectra दिया तो उन्होंने hydrogen discharge tube use किया था for the source of radiation. Okay, so the source of radiation here is hydrogen discharge tube, right? And the discharge tube, it contains hydrogen gas, right? Discharge tube में क्या था? Hydrogen gas था, and the pressure is maintained as a very low. The pressure was very low and the potential difference is very high. Okay, see. So the source was hydrogen discharge tube, right? And this discharge tube, it contains hydrogen gas, right? And the pressure was very low, and your potential difference, right? Your potential difference is very high. That's the condition, right? That's the condition which he used in his experiment, right? And he gave this wavelength. See, so the hydrogen spectra, it is obtained by doing experiment, right? By analyzing the light which is emitted by discharge tube, right? And it contains hydrogen gas under high voltage and low pressure. The condition was that high voltage or high potential difference, you can say, or low pressure. Okay, and we know delta E, right? The energy change in energy is equals to 13.6 into 1 upon n1 square minus 1 upon n2 square. Okay, we have derived this in the previous class. Previous class में हमने ये derive किया था, like electron volt में होंगे तो 13.6 something like that, right? And we have derived, we just take n1 as a ni initial, right? When the electron transitions from one energy level to another energy level. So we just use this formula. Remember? Hmm? Remember or not? See, we have used this in the Bohr's atomic theory. Right? This. Right? When the electron jumps from one energy level to another energy level. Right? तो हमने ये derive किया था, right? 13.6 into z square upon 1 upon ni square minus 1 upon nf square. This formula I'm just talking about. Remember?
Yes, ma'am.
आप लोग रिवाइज नहीं करते हो आफ्टर द क्लास. इफ यू डोंट रिवाइज यू विल फॉरगेट एवरीथिंग बच्चों. दिस चैप्टर इज वेरी लेंथी, दिस चैप्टर इज वेरी वास्ट, यू कैन से. तो आप सारे टॉपिक जब भी क्लास हो, आफ्टर द क्लास जस्ट सिट and just revise those topics, and at last do 1 to 2 numericals based on that. Okay, then only you will complete different topics in a one day. Because आप एग्जाम्स के लिए आप रखोगे पेंडिंग, तो एग्जाम्स में तो बहुत सारा टॉपिक्स होगा, इट विल बी वेरी वास्ट टू कंप्लीट दैट यूनिट और एनी टॉपिक. ओके, आपके लिए वो प्रॉब्लम हो जाएगा. नाउ सी, सो एटॉमिक स्पेक्ट्रा. Yeah. So this formula I was talking about, delta E, the change in energy is equals to 13.6 into, because Z square we were used there, right? 13.6 into Z square. But we are talking about hydrogen, right? So hydrogen, we know that one hota hai, so no need to write the Z square. Okay, so we are just writing 13.6 into 1 upon N1 square. N1 is the low energy level, right? Low energy level means the initial energy level, and N2 is the high energy level. Okay, so just remember this formula. Next, the wavelength or wave number of various lines, right? Various lines in the visible region, they can be expressed by a equation, and this equation is known as Rydberg's equation. इस equation को क्या कहते हैं? It's known as Rydberg's equation, and this one is very, very important. Okay, for the numerical point of view. So nu bar, what is nu bar? So nu bar, we know that it is wave number, right? And wave number is thus inversely proportional to the, it's just inverse of the wavelength, right? So 1 upon lambda, which is equals to RH. What is RH here? So RH is the Rydberg constant into 1 upon N1 square minus 1 upon N2 square. Okay, so Rydberg constant for hydrogen atom is 109677. Okay, remember the value of Rydberg constant. Okay, what is N1 here? So N1 we will just take as a lower energy level. For example, electron, it jumps from N2 to N3, right? So this N2 will be the lowest energy level, right? This is your N1 and this is your N2. N2 will be 3 because lower energy level is this and the higher energy level is this. And electron is transitions from N2 to N3, right? So initially N1 we just take, and final transition state we just take as a N2, means the higher energy level. Got it? So this formula is very important, right? Now see, the Rydberg constant value is not same for all the elements. Okay, it's different for different elements, right? But आपको सिर्फ हाइड्रोजन के, because questions is based on hydrogen, right? Questions जो अभी पूछे जाएंगे, so it's based on hydrogen. So just remember the Rydberg constant for hydrogen. Okay, but don't think it's common for every element. So Rydberg constant value is not same for all the elements. Okay, but for hydrogen like a species, right? Like H, a hydrogen के for example कोई isoelectronic species है, right? Like H, helium plus, right? Helium plus भी just like a hydrogen है, right? Because it also contains one electron. Lithium 2 plus, it also contains one electron, right? This beryllium 3 plus, right? It also contains one. Just these species are just like a hydrogen, right? So for this type of species, we just take Rydberg constant. You just have to multiply the RH value into Z square, right? Z is the atomic number. For example, lithium is there. Lithium ka we have to find. Okay, so just multiply 109677 into your lithium atomic number. Okay, 3 square. Clear?
Yes, ma'am.
Yes, ma'am.
Okay. So that's for hydrogen like a species only. Okay, just multiply it. Rydberg constant का form आपको value पता होना चाहिए, and just multiply it by its atomic number. You will get the value of Rydberg constant. Okay, and if you get the value of Rydberg constant, so you can also find the value of your wave number, right? Because we know the formula for hydrogen atom is this, right? This is for hydrogen, right? This formula is for hydrogen only, right? But if we are talking about the hydrogen type of species, so you just have to multiply it by Z, right? Means your atomic number. Okay, so the formula is nu bar is equals to, the same formula will be there, but you just have to multiply it by Z square. Okay, and just remember N1 is always less than N2. N1 जो होगा हमेशा N2 से कम होगा. N1 is your lower energy level, lower energy level, and your N2 is your high energy level. Clear? Okay, now it's very important. Okay, now see the hydrogen spectra. It is a set of discrete wavelength, right? And wavelength of electromagnetic radiation, right? Which is emitted by hydrogen atom. तो जब इलेक्ट्रॉन ट्रांजिशन होते हैं बिटवीन द एनर्जी लेवल्स, सी you must have a question that why these type of, see, why hydrogen shows multiple state. You can see over here, see this diagram. Okay, see this diagram. This is the line spectrum of hydrogen, right? Line spectrum of hydrogen. But you must have a question in your mind that hydrogen has only one electron, right? Hydrogen के पास तो सिर्फ एक ही इलेक्ट्रॉन होते हैं. But why it shows the multiple lines? Okay, so the hydrogen spectrum has multiple lines. Why? Because single electron, it can occupy different energy levels, right? This n is equals to 1, n is equals to 2. This is the energy levels, right? Or you can say the shell number, right? This is again, you can say the shell number or energy levels, right? Which was given by the Bohr, right? Energy according to the energy level. So this n1, n2, n3, and so on. This is the energy levels. So the one, because hydrogen has only one electron, but its single electron, it can occupy different energy levels, right? And the transitions between them, उसमें transitions होते हैं, right? And they emit photons, right? वहां पे वो energy release करते हैं, energy emit करते हैं in the form of photons. Okay, so that's why these are the series, right? वो जो spectrum होते हैं, they have a multiple lines, and you can see over here the multiple lines. Okay, so this is the line spectrum of hydrogen, and it has they are classified into various series, right? Various series. If the electron transitions from n1 to n infinity, right? अगर n1 से n infinity की तरफ जाए तो it's a Lehman series. You can see over here, this is a Lehman series, right? And if it is n2, n2 से n infinity, right? n2 n2 से n3 पे भी transition हो सकता है, n2 से n4 भी, n2 से n5 भी, and so on. From n2 is the minimum lowest state, right? And for the Balmer series, right? So there are 1, 2, 3, 4, 5 series. Just remember this 5 series. So see, you can see first series, Lehman series. So for Lehman series, n1 क्या है? It's the lowest lower energy state, lower energy level, because energy यहाँ से electron jumps from this, right, this to n2, from electron jumps from n1 to n3 and n1 to n4, okay, n1 to infinity. Okay, so when the lowest energy state is 1, okay, and when the transition happens between n1 to n2 or sometimes n1 to n3 and so on, so n1 to n infinity, so it is known as Lehman series. ये कौन सी series है? Lehman series. And the region of Lehman series is ultraviolet. Okay, Lehman series कौन से region में exist करता है? तो it exists in ultraviolet region. Next is your Balmer series. So for Balmer series, you can see over here, right? This is the Balmer series. यहाँ से start होता है. So it starts from the n is equals to 2, right? When the lower energy level is 2, right? So, and lower energy level is 2. So your initial, or you can say that the high energy level can be 3, 4, 5, 6, right? Electron can transitions from 2 to 3 भी जा सकते हैं, 2 to 4, 2 to 5, and 2 to 6. Okay, so these lines shows that. This first line you can see in the Balmer series. This is the transition when the electron jumps from n2 to n3. This is the n2 to n4. This third one is the n2 to n6, right? This n5, n6, and from n2 to n infinity. Okay, means is that you just have to remember the lowest energy level. N1 value is 2, but the N2 value can be 3, 4, 5, 6, and so on till infinity. Clear? समझ आ रहा है आप लोगों को? आयशा and Sanidhi?
Yeah, ma'am.
Aisha, if there's any doubt, you can please ask me in between. Okay, and this Balmer series is the region of visible, right? Visible region जो होता है, visible region जो भी होता है, wavelength, and you must have remember, I give you the notes. What is the region? What is the frequency and wavelength of visible region, ultraviolet, near IR, infrared, etc. So these you just have to remember that, right? तो Balmer series किस region में आता है? तो it occurs between the visible region, right? Visible region का जो भी आपका wavelength and frequency होता है, तो it falls in this region. Okay, so Balmer, that's the Balmer series. Paschen series, so lower energy state is 3, right? And it occurs, the region is near IR, right? Near infrared region. Bracket series N4, N1 is 4, and it occurs between the region of IR, infrared. T fund series, so 5 and far IR. See, the question किस type के आते हैं? So question sometimes come just like the electron, it transition from N1 value is, for example, 2, and it transitions from N2 to N5. Okay, so now tell me what is the value of wavelength, wave number, right? Sometimes they will ask you energy, sometimes they will ask you the wave length. Okay, so that's how you just calculate. You should know what is, if n is equals to n1 is equals to 1 and n2 is equals to 5. So what is the n1? If n1 is equals to 2, then it must be a Balmer series, right? So Balmer series के बारे में बात हो रही है when the lowest energy state is 2. Okay, and the high energy state can be 3, 4, 5, and so on. Okay, means your N1 is always less than your N2, right? Equal to bhi nahi hoga, it will be less than N2. Just remember that. Clear?
Yes, ma'am.
Okay. There is a formula for calculating the number of emission line. How many, for example, sometimes they will give you some atomic number, and they will ask you what is the maximum number of transition lines that is given by an electron, right? When it is transition from N2 to N1, right? जब N2 से N1 की तरफ वो transition हो रही है, right? So what will be the maximum emission line? So maximum number of emission lines that is given by an electron is from N2 to N1. Just remember, from higher energy state to lower energy state is given by this formula, right? So what is the formula? So it's N2 minus N1, right? N2 is your high energy state minus N1 is a lower energy state into N2 minus N1 plus 1 upon 2. Okay, so this is the formula. You just have to remember, right? Maximum number of emission line. Clear?
Yes, ma'am.
Okay, now if you have any doubt, you can ask. Or let's do one question. Let's see how question come. Okay, so question is, find the ratio highest wavelength of Lehman series to the highest wavelength of Balmer series. Okay, we have to find the ratio of highest wavelength of Lehman series to the highest wavelength of Balmer series. Okay, so we know that there's a energy और wavelength के बीच में कैसा relationship होता है? So it's inverse relationship, right? So if highest wavelength means lowest energy, right? Means the lowest energy. So if we talk about Lehman series, right? So what is the N1 value, right? Tell me what is the N1 value, lower state for Lehman series, right? So it's 1, right? See in the left. Okay, so for Lehman series, N1 value is 1. And suppose N1 से transition कहाँ हो रहा है? N2 it will be 2, right? From one energy state to second में energy transition हो रहा है electron का, right? So Balmer series Balmer series will be N1 always equals to 2 for Balmer series, right? Lower energy state is 2 and your final energy state suppose that is 3. 2 से 3 में jump हो रहा है and here in the lemon series 1 से 2 में, right? Now just calculate the for lemon series 1 upon lambda will be equals to what is the formula for? See the formula. This is the formula, right? Wave number which is equals to 1 upon lambda is equals to RH into 1 upon n1 square minus 1 upon n2 square, right? And we have to calculate the ratio of wavelength, right? Ratio of wavelength. So RH will be equals to 1 upon n1 square minus 1 upon n2 square. Right? I'm just putting RH over here because हमें ratio निकालना है, so it will be cancel out. When I put it this, it will be cancel out. Now 1 upon what is n1 square? What is n1 for lemon series? So it's 1 n square minus 1 upon. Okay, so you will get okay. Similarly, आप इसके लिए भी calculate कर सकते हो. Like for Balmer series, 1 upon lambda b. Lambda b, I'm just writing it for Balmer series wavelength is equals to RH into 1 upon 1 and 1 is 2. So 2 square minus 1 upon 3. Okay, because we have to calculate the, we have to find the ratio. Means 1 upon is 1 upon Balmer ratio. Okay, the value will be, what is the value? So it's RH into 1 minus 1 upon 4. Rydberg constant into, what is the value for Balmer series? 1 upon lambda b की value. So it's 1 upon 2 square minus 1 upon 3 square. This will be cancelled out. Okay. Now solve it. 3 upon 4. And it will give you 1 upon 4 minus 1 upon 9. And minus 4. So it will give you 5 upon 36. So 5 upon 36. This is 1 upon lambda L upon 1 upon lambda B value. Okay, now solve this. Just inverse this, you will get 1 upon B upon 1 upon L. When you inverse this, you will get the value. Just a second. First, let me find this value, then we will inverse. Twenty 7 upon 5. Okay, so that's the value. When now you can just reverse this 1 upon, you will get lambda B upon lambda L. Right. So the ratio of what they have asked, what is the ratio highest wavelength of Lehman series. Right. So Lehman series that they have asked first. So you have just to write Lehman series wavelength first. So lambda L upon lambda B will be equals to 5 upon 27. Means 5 is to 27. That's the answer. 5 is to 27. Clear?
Yes, ma'am. It's clear.
Yeah.
Okay, so your chapter is completed now. If there is any doubt in any topic, you can ask. Okay, so in the next, from the next class, I will start the third chapter, which is periodicity. And inshallah, I will take one more class, one extra class in which I will discuss questions. Okay, important questions based on this chapter. Atomic structure के जो भी important questions होंगे, I will discuss it over there. Okay, in the extra class. But from the next regular class, I will start the periodicity chapter. Okay, so the chapter is completed from my side. Now, just ask your doubt. If there is any doubt, you can ask. Everything is clear?
Yes, ma'am.
Yeah, ma'am.
Okay, so now it's your turn to just revise all the topics. Okay, just complete the chapter by yourself. Okay, एक topic cover करो, just revise it and solve the question. Right, solve the questions from the NCRT, in-text question and all the back questions. Okay,
Okay, ma'am.
okay, so that's all for today. Thank you, everyone.
Thank you, ma'am.
Thank